Yeah, so today we will see Wi-Fi, how Wi-Fi works mostly. Uh, so Wi-Fi components, Wi-Fi pipelines, etc., etc. I mean, hopefully we get better idea of Wi-Fi today. So maybe in practically also we'll do some things. If you have your laptop, everything is ready, we can try it. But that's morely outside of the class. So if you look at, we were doing networking, most of the networking, we thought it's mostly physical wires, physical connections or physical wires. But at our home, Wi-Fi, we don't have wires. We call wireless communication. That's what Wi-Fi is, which means I can send data without physically connected to your device or whatever that is. So that is what we call wireless communications. That's what Wi-Fi is. If you look at Wi-Fi, so there are some components. Say one is, let's say you probably see router. That's one. You will see some username and password. Maybe you will usually encounter, right? Every time you want to connect to Wi-Fi, you look for which signal is coming. You enter username and password, and you connect to it. That's how typically you do. But there are some components in Wi-Fi. I'll tell you one by one. The first component is, of course, router, which is just a physical device. Obviously, you know it, that connects, that sends and receive data, or that transmits data, or passes data, whatever you call it. Uh, uh, Passes data, it's called. Passes data from clients. Client means your devices like mobile phone, laptop, all these devices, to external internet outside, let's say. So that's what router is. Router is basically a physical device that passes the data from your client, phone, laptop, whatever, to back to external internet. It has, of course, the MAC address, obviously. Wi-Fi also has, router also has IP address and several addresses you can have, but these two are important. So then there is another terminology called access point, shortcut AP we call. So access point is also like a small device that sends Wi-Fi signals to your client, mobile, whatever, laptop. So actually, access point is the one that is almost like a device, small chip that sends Wi-Fi signals to your clients. You can see it, access point, let's say Google it. You will see these kind of physical devices like something like it could be small access point. Typically nowadays in modern routers, everything is included in router. You have access point included in router, router also included. But if you separate them out, access point is a physical small chip, let's say. It sends Wi-Fi signals. Router is also a device which sends data to from many devices to the internet. So there is also another thing called modem, they call modem, which is what it's connected to ISP, Internet Service Provider. You can think like external internet. So that's it. These three components you typically have, physical components, all three. Of course, router is physical device, access point is a device. Sometimes it's mixed with the router, but it's a physical device. Modem also in a physical device, you can think. So nowadays, if you look at modem, we have different types of modems. One is like a dongle kind of thing. Another is like a pen drive. But you can also have modem in fiber optic also, like a physical wires. So that's also a modem in a way. In a way, right now, if you're looking at the Wi-Fi has router, access point, modem. All three combined, they call router. So each one does different tasks. Of course, access point sends you the Wi-Fi actual signals. router actually sends data between your computer to outside. That outside is actually is the modem. So in a way, router transmits the data from your laptop computer to the modem. Modem onwards, you will get the internet and everything. Same. So in typical home Wi-Fi, so all three are connected. Home routers, all three are integrated. Typically, they all are in one device. You will get like final Wi-Fi router. That's what they call. Uh, but let's say you have old laptop. It doesn't have any Wi-Fi. For example. So what do? You will buy something like Wi-Fi adapter, something like a small chip. It's like access point only. You look at Wi-Fi adapter. It could be small chip, it could be big, depends on the thing. You can see something like this. So that Wi-Fi adapter has a access point. It sends data to you and the Wi-Fi things. So this is the access point, sends and receives. So that's the components of Wi-Fi. So you can think like three different components. Each component does its job. Now let's see software. So far we discussed hardware only. Let's see software. Software is mostly like every Wi-Fi access point has something called SSID. You can think like a Wi-Fi name. Example, let's say here, if I look at it. So these are different Wi-Fi names. So we can call SSID. We use software here. Some Wi-Fis have something called password. If enabled, you can have. So you can have a Wi-Fi without password also. You can directly connect to the Wi-Fi without password. Of course, secure means password you have to add it. That's another software layer. Some Wi-Fis have something encryption. Encryption could be like a let's say small, let's say what do you call like low encryption, medium, strong. So low means obviously anybody can decrypt it. Medium means of course kind of plus or minus. Strong means no one can touch it. And anyway. So nowadays Wi-Fi we have different types of encryption algorithms they use. So we'll see these algorithms later. But right now just think like VPA2, VPA3. If you use this one, this is old, no encryption, anybody can attack. So this is currently enabled. It's medium in a way. This is the highest level of strong security. If any Wi-Fi uses VPA3 encryption, they are very good. If anyone uses WPA, you can attack very easy. I mean, it's easy to attack, easy to detect. This is somewhat medium. You can attack, depends on if they use strong password, you cannot. If they use little bit medium passwords, you can pretty much act right. What else software is required? Mostly that only. Maybe you can have some tools, admin tools. Admin tools like you can apply some MAC filters. For example, you can stop some devices. For example, you can filter, I mean, you can add one MAC address saying that, hey, this MAC address should not enter connected. In a way, MAC address is permanent, so obviously that device will never be able to connect to you. So you can prevent spam or anybody like block somebody. Some like external tools are there. Maybe you can bandwidth. Bandwidth is another thing. Okay. Bandwidth. Most Wi-Fi's you see bandwidth is like either 2.4 gigahertz. So I'll tell you what that is, but or 5 gigahertz. So most Wi-Fi's these two only you see. So what this means is gigahertz means like it's 2.4 billion. You can think like a cycles they call. But okay, before that I have to tell you. So what is a Wi-Fi signal? If you look at Wi-Fi signal, obviously we cannot see the signal with our eyes, but there is something called radio waves. So radio waves is a waves in the air, like plus or minus, like here. These waves we cannot see with our human eyes, but they are there. They're everywhere, like around us, right? But you cannot see them. So these radio waves actually, you can see some imagination. Something like these kind of waves, like these called wave, like up, down, up, down, up, down, up, down. Yeah, something like this. So this is like up, down, up, down, up. This we call cycle. Up, down is one cycle, up, down, another cycle, another cycle, another cycle. So 2.4 gigahertz means 2.4 billion waves per second, which means for 1 second, it can carry 2.4 billion waves around us for 1 second. 5 gigahertz means 5 billion. 5 billion waves. 5 billion waves per second. So the more waves means the faster but long range, like here in the room. The less number means slower internet, but longer range. So there's always trade-off. If you want longer, you use 2.4 gigahertz. If you want fast data transmission, you use 5 gigahertz. So let's see what we use. Let's go Wi-Fi settings. Both, you can use both of them. Doesn't matter. Yeah, you can see some people give 5G and all these. Let's see. Network settings. Okay, here they don't give. You can see it's a weak security because it uses WVP encryption. It's not a good one. So they're recommending you to use this one. You see this one. This. Sorry, wait just a second. This one. So they're saying VPA is not secure. You use VPA 2 or VPA 3. So right now we have our VPA weak security. We can easily crack, right? You can see Wi-Fi, MAC address, everything. But I want to see the bandwidth actually. Wi-Fi bandwidth details. So TCP data, DNS, proxy. Yeah, I cannot see it. But yeah, there is either 2.4. I'm not the owner of the Wi-Fi right now, so I cannot log into the network also. But either 2.4 gigahertz or 5 gigahertz, depends on the speed. So that is the software layer, or maybe radio waves is medium, like software plus hardware. The waves are hardware, but the waves carry the information. The information is binary on. Example 1, 0, something like that. Top means 1, bottom means low. So the wave means you can think like it carries that binary information. So that information is coming to your PC or your laptop. That information also going to their something like that. So that's how Wi-Fi ideally works. So if I have to tell you the end-to-end flow, let's say I send a WhatsApp message. Hi. The WhatsApp message is communicated into bits. Example. Now these bits are transmitted into air signals, radio waves. Example. In radio waves, this data is encoded into that wave format, like up and down, up and down. So these waves or signals received by Wi-Fi access point. Wi-Fi access point also send that to the router send it to external modem and so on. Example. Router, modem means internet, another side. That's it. Reverse also same way. From external modem, internet, you get some data. You will do everything is reverse order. First modem comes, then router comes, then access point, Then you have again radio waves, then your data, and finally your computer, PC, whatever. So this is the typical flow. Like this is how Wi-Fi data typically sends the. So let's get more. Yeah, physical network. You have wires, mostly optical cables. You have radio waves. Those also like uh, router, access point, modem, home router, always combined. Clients are laptops, phones. SSID, password, encryption, frequency, etc. So this is the process. I bind the radio waves, access point, router, modem. Okay, let's see some diagram. It's a flow only. Same. Your laptop sends the data in binary format. The binary format, your laptop has a Wi-Fi chip that converts, that transforms that binary into radio forms. Those radio waves is going there here. The Wi-Fi signal captures that radio form, decrypts the data and further back. So that's how physically data transfers actually. See some devices. Okay, let's see some visualization. Yeah, any questions on how Wi-Fi works? So far, we are just talking about how Wi-Fi works. That's it. We're not talking about attack or nothing. We just know how Wi-Fi works. Then only we can see where to attack, where not to attack. Yeah, any question up to this point online? Any? Okay. Yes, any question, anything? Okay, let's see. Okay, now let's see that. So as I said, like so far we understand how Wi-Fi works. Now, if you think like an attacker, so you are an attacker now. You know how Wi-Fi works, obviously. Now you want to do some attack or something. Okay, there is a question. Let me see. Flow details. Okay, can you explain the flow details once again? Okay, so we'll summarize it. Okay. Yeah, so flow is something like this. Your device, let's example, your phone is connected to your Wi-Fi. Example, you send iMessage on WhatsApp and send the submit. The message will be converted into first binary, zeros, ones, and zero. And your phone or laptop has inbuilt Wi-Fi chip that converts that data into radio waves. Example, the waves are spread around your room. And your room, you have Wi-Fi device also or access point. That access point will capture those waves, physical waves, and decode it, send it to the router send it to the modem. Modem means external internet, ISP. So that's how it travels from one side. The other side also same. You will get some data from the internet to the router, from router to access point. The access point converts that data into radio waves, and those radio waves will be sent to you, your phone. Your phone converts that into binary data, and that binary data is shown on your message, like whatever. In a way, you only thing you flow understand is how this binary data is like converted into radio waves. Is this somewhat physics question actually? But yeah, you can see radio waves up means 1, down means 0. It's simple. Up 0, up 0. So let's say if I want to convert into radio waves, let's say 10. So what is 10 for binary? Example, this is binary code. So I can have a radio wave of up, down, up, down. So that sends the message of 10. Similarly, if I give a message of A, example, uh, you typically convert A into some number, let's say 56 example. You give binary code for 56. You will send that as a wave. So that's how some physics are there because radio waves we cannot see. It's a physical thing. But think like a physical wave converts the data into binary to radio waves. That is the conversion you should understand. But that is physics actually. It's not a computer science. It's physics mostly. Like analog to digital, they call analog to or digital to analog. So zeros and ones are digital. The waves are analog to digital communication. There. Like AC, DC, again, it's a lot of physics actually, but something like that. Your computers, everything understand digital, but physical devices have analog signal, like sensors, all these analog signals. So you have to convert between this and this and this, something like that. Yeah, something like this. You can see you have a digital binary data, you convert it to a signal, or you have a signal data, you convert into binary, depends on your interest. So that is the only part I think you should need to focus more because it's physics. But the rest, everything you can, I'm pretty sure you will understand, like, suppose here. Hope it's a little clear now. Now let's see you're an attacker. So there are a few things. First, if you're an attacker, you don't know Wi-Fi password name. That's the first assumption. You don't know anything about Wi-Fi. You're just connected. You just come here in the location, but you can see Wi-Fi signal. Anybody can see these access points. I can also, again, I cannot touch it. If I touch, Zoom will stop. But I can click on it. It will ask for password, typically. The first attack you probably want to do is how to get the Wi-Fi password. It's a simple thing. Wi-Fi password. Yeah. That is the first attack you probably want to do, typically like. So let's see how we can focus on Wi-Fi password attacking or hacking. But before that, I should tell you everything we do for legal within boundaries. Maybe I'll just a second. Yeah, just a second. Where is that? Disclaimer is not there. Yeah, I just want to, since it's recording, I just want to display the disclaimer. That's it. But it looks like it's not there. So what I do is, so yeah, maybe I'll use this as a disclaimer. Yeah, so everything we do it for educational purpose only, not to attack anybody, no unethical usage. So we're not responsible for any of the attacks. So just want to tell you. Yeah, let's see Wi-Fi password attack. So before you need to know Wi-Fi password attack, you need to know a few things, something like Wi-Fi monitoring mode. So there is something called Wi-Fi monitoring mode, which means you can monitor the Wi-Fi signals without no need to log in anything. You can simply turn on the Wireshark example. You can sniff like a Wi-Fi signal sniffing. Sniffing. You can sniff the signals, what signals are coming like. You don't need like login or anything. You can only sniff signals if you turn on the Wi-Fi monitor mode. So you can Google it if you based on your OS, how to turn on. I cannot do it right now because it will stop the Zoom and everything. But you enable the monitor mode mostly. That is the first step. So when you enable the monitor mode, you can capture all Wi-Fi signals into your, let's say, Wireshark example. So that is we call Wi-Fi signal sniffing. So let's say I go to a coffee shop. I don't know anything about coffee shop, Wi-Fi username, password. I don't know anything. But what I do is I have my laptop. I turn my Wi-Fi into Wi-Fi monitor mode. I just wait for 10-15 minutes example. So what I turn on the Wireshark capture. I'll just wait for a while. So what happens is it will capture something called a four-way handshake file. Four-way handshake or four-way packets on Wireshark. Four-way handshake we call. It's like a four records usually. Like if you can capture that four-way handshake. So what is a four-way handshake? I'll tell you. Let's say this is me. I'm the good guy. I'm the user of the Wi-Fi. There is a Wi-Fi somewhere. I know the username and password because I'm the authorized person. What I typically do, I click on here. I click on some Wi-Fi. I just click on password. I enter the password. Done. So when I click it, it will. All these are signals only. Everything is around us on. So when I enter Wi-Fi name, Wi-Fi password, everything is captured as a signal only. All these signals is we call authentication example. Authentication process is actually the four-way handshake. So if you are a monitor mode example, let's say you are one guy, you turn on the monitor mode, you are capturing the signal. So I'm the normal authorized guy. I try to connect to the Wi-Fi with password enter. Now in this process, the physical signals are there. Those signals you can capture. Those signals we call a four-way handshake. So these are the physical signal you capture. You don't know password anything, but you can capture this four-way handshake, which means you can capture the authentication process, right? Because I'm just connected to Wi-Fi. If I'm not connected to Wi-Fi, then obviously you cannot capture that four-way. Sometimes attackers, what they do is they do something like de-authentication. Example, you are user one, you are connected to Wi-Fi, already connected, your everything on. I'm the attacker. What I do is I will send a de-authentication request to your phone, your user, your phone, whatever. Then your Wi-Fi will be off. Wi-Fi off suddenly. Then you think like, okay, maybe I need to connect again. You connect again. Now in this connecting process, I capture this signal. So what I do is first you are connected, so I don't capture that four-way handshake, but I send you de-authentication request. Let's say your Wi-Fi will be off. Then you'll hey, my Wi-Fi is off. I'll connect again. While you connecting again, I capture the signal. So that is what we call de-authentication process or de-authentication request. Something like that. If you're already connecting again, then I capture the signal. So that is the first step you do attacking any Wi-Fi. You capture the four-way handshake. So maybe I can show you some previously captured, but you can also do it at your home anywhere. Just turn on monitor mode on, sit for a while. It will capture the four-way messages on your Wireshark. You save it somewhere. That's all. So yeah, let's see. Let me any questions meanwhile. Let me know. I'll look for some already captured frames. So Wireshark is PCA. So I'll just show you already some. Is this mine or somebody else? Wi-Fi. Maybe this one, I think. This one, yes. This is the capture. Wi-Fi uses this protocol 801 802.11. So it's a protocol name, wireless protocol 802.11. It's a wireless Wi-Fi protocol, wireless protocol. It's a protocol name. Just like you have HTTP protocol, you have different protocols there. So this also is kind of like a protocol to send data. You can see this is already I captured the four-way handshake on Wireshark. I'm just showing it to you what it looks like. Few things you observe. So these are you can see source destination protocol function. Protocol you observe all are wireless, all are 802, all wireless signals. Length of course varies, depends on signal. Now if you look here, there is something called beacon frames. So many are there, but let me filter it. Four-way handshake on Wireshark or Wi-Fi. Now I want to filter. Those four messages. So these are the yes, this is the one. So this is the four-way handshake message. You can see this is the first message. Then this is second. Second is sent twice for some reason. This is third message. I think fourth is missing, or maybe this is not the right packet, maybe. But anyway, you can see three messages, right? 1, 2, 3. So first is this access point to the client, for example, router to your phone. Second message, your phone to client access point. Third again you will get. Fourth again you will get. So it's like a, but each time you will share some extra information. So these are the extra information. Again, these all are very detailed, but we'll see later. But it's like a handshake. Like I send you one code. It's like a encryption token. I send you A, you send me B. I send you AB, you send me BA, example. That means we are communicated well. So these four messages sent. Basically these four only, but fourth one is not there. Maybe I'm not able to capture on this packet, but you can try on your own. You will capture four messages. If you can capture these four messages, the Wi-Fi password is here only somewhere. You will see it. You will not get direct password. The password is usually hashed, but you will get the hash password. Right? You'll have to decode it, but that's a different method. But first step is an attacker. You try to find these four messages. That's a first step. Maybe after encryption, hash tracking, you can be able to do entire act one fully. But since for today class, you focus on only capturing four-way handshake. That's the good one. And save it. Save it as a somewhere.